So next up, we have Mackenzie, who is, I'm sorry, my notes are slow, but is a developer advocate with a passion for DevOps and code security, co-founder and former CTO of a health tech startup. And I'm not going to go any further. I'll let him introduce himself more than that. I'm really excited. We are going to be talking about, oh gosh, he's got a long title too, Exploiting Exposed Credentials in 2022, How Adversaries Discover and Exploit Leaked Secrets. Nobody leaks their secrets. Nobody would ever commit to their GitHub repository a hash or share it on a live stream or anything like that.
I've never done anything like that. No way. All right, let's bring Mackenzie on. Hey, Mackenzie, welcome.
Hey guys, how you going?
Good.
Going well. How are you?
Good. Just chuckling in the background as you're talking there. But yeah, no, great to be here.
Great to have you. Well, without further ado, we'll get out of your way and let you take it away.
Well, excellent. So as was just being said, I have to work on shortening my titles a little bit, but I'm just trying to get as much as I can in there. But we'll be talking about exploiting secrets, exploiting credentials, what happens when you leak them, how secrets are leaked, how adversaries find them and use them basically to attack your organizations. So I like to start. I know most people probably kind of know what secrets are, what digital authentication credentials are, but I just want to start at the basics, get everyone kind of up on the same page, and then we can dive into some of the more technical meat of the presentation. So let's start with what are secrets? So secrets, I'm typically referring to things like API keys, your credential pairs, the credential pairs to your database, could be security certificates, could be a whole range of things. And the key that they all have in common is that these are authentication strings, right? We use these to authenticate ourselves with other systems, internal services, external services, SaaS tools. So these are really the crown jewels to your organization, and attackers really want and also likely need these to be able to get into your systems. They can use them to elevate their privileges. They can use them to what we call move laterally, so leapfrog into different services once they're inside. So these are really the crown jewels of your organization, and you really want to protect them. But we're at a bit of a problem with secrets, and that is that they're both highly sensitive that we need to protect, and we need to distribute them widely because a lot of people need secrets to be able to do their job. And this is because of a pretty big shift in how we build software today. Because way back when, we used to build these monolithic applications. These are things where the software needed everything to run was internal. So everything that software needed to run was inside it. But now we can leverage lots of different systems. So the simplest example is maybe a payment system, right? If you're building some software and application that needs to process credit cards for payment, are you going to build that all out yourself, find out what the financial regulations are, or are you just going to use Stripe or PayPal or some other service? So we extrapolate this to a lot of areas in our organizations. It could be open source components too that we're building on, but it can be SaaS platforms, it can be managed services, can be cloud infrastructure. So this change has meant that we need to handle a lot of these secrets, right? And it means we need to distribute them and create a huge number of these in any given application. Now, the second problem is that code is actually a really leaky asset. I want to give through some examples of kind of how code has leaked into the public realm. But basically, we don't have adequate protection around code, and this is by design and is important because code is something that we collaborate on, and we need to be able to do that. But it means it's hard to protect. So when we get secrets inside our code, it creates a real problem. And then the last kind of piece to this fragile pyramid is that software developers are under a lot of pressure. We're trying to get our release cycle shorter. We have lots of competition. We're building very, very quickly. So this all together kind of combines this perfect storm for these secrets, these crown jewels of our organization to leak, to kind of be exploited by attackers. So just quickly, we can give a pretty good example of kind of how many of these secrets are. So let's say that we're building an application. And I used the example about Stripe before, but we can extrapolate this to lots of different services, right? If we're building the application in a Django framework or using Django, then we have Django keys that we need to manage. Maybe we're connecting into Twitter. Maybe we're using Okta as our authentication. Maybe we're using Algolia as our search function inside our application. So all of these different systems need to leverage secrets to be able to connect to them. And all of them can contain a lot of sensitive information or provide opportunities for adversaries to be able to jump between them. And then once we've built our application, right, we're not done with secrets yet because we need to host this application. We need to kind of make it accessible. So our infrastructure that we use deals with secrets too. Maybe we're hosting this on our AWS cloud. And so now we need to deal with AWS credentials. You know, we have to manage our code. So we're dealing with Git credentials. We have testing being done in our CI/CD pipelines when we're deploying apps. So we have credentials for those, and they can be really sensitive. I'll show an example of that. Right, so once we've built our application, we have some infrastructure in place, people can access it, right? Probably the marketing teams, the sales teams are going to want integrations. So maybe we have Salesforce integrations, Grafana, Slack, all these other different areas. So now we have more secrets to deal with. And we haven't even started talking about the internal microsystems or microservices that you're creating that also probably leverage secrets for authentication, but aren't a named service like the other ones on here. So this is an oversimplified version, but we can see that very quickly we can end up with hundreds, thousands of these different services, and then we can end up with hundreds and thousands of different credentials, different secrets that we need to access them. So this is largely kind of the problem of how many secrets that we are dealing with as an organization today. Now, the last part of that component is the unwanted distribution of these secrets. Now, they can kind of leak in a lot of different ways, but the number one way that we lose track of these secrets is through code, particularly our version control systems. So you can imagine a situation where a secret gets hard-coded into source code, right? The developer is quickly trying to do something. Maybe they hard-code a credential to get something working. Maybe they're intending to remove it later before it goes on to the master, but it ends up in our source code. It ends up in our version control system. Now, immediately, this is then cloned onto multiple different developers' machines, right? So we've now lost track of where that secret's ended up. It's in our source code, plus it's on all of the different developers' machines. Maybe it's been copied into some messaging systems like Slack. It's probably backed up into different servers everywhere. And it may even end up in our running application or end up in our deployment tools, maybe in Docker images. And the key thing about this is that we actually have no visibility. We have no idea where this secret has ended up. So we don't even know that this secret has actually been compromised. We don't know that this secret is in backups, is in different developers' machines. We don't know, we can't restrict who has access to it. So we end up with a problem that collectively we call secret sprawl, right? And attackers really rely on this concept of secret sprawl to be able to kind of exploit these secrets. And I have a quick demo that I want to show you here today. Now, they say you should never do live demos, but we're going to give it a go and we'll hope for the best. Usually you can rely on bad guys pretty well. So here I have a configuration file, a Python configuration file in a fake project. And right here we have an AWS credential. Now, this AWS credential isn't going to help you much if you want to do some Bitcoin mining, but what this is a Canary Token. Now, Lewis briefly spoke about Canary Tokens in an earlier session here, but essentially what this is going to do is every time someone tries to exploit this credential, they're going to let me know. It's going to notify me. And what I'm going to do is I'm going to do the number one sin that you can do when dealing with secrets. And I'm going to push this secret or this file into a public Git repository. So I'm just going to quickly do that.
No, Mackenzie, don't do that. Oh,
it's done. It's done. Now, what I have here is I have on my page, as I said, this is a Canary token. What's going to happen is this is going to let me know every time someone tries and access that token. And I have about 20 minutes left on this presentation, and I'm going to see at the end how many people between now and in 20 minutes have tried to access my AWS credential, right? And I want to do this for a couple of reasons. One is I want to show that this problem is so widespread, but I also want to show that actually source code is being monitored, and there's a number of ways that attackers can do this. And I'll talk about that in a bit later. But now, let's have a look at some cases where attackers have been able to exploit these secrets in real life, not just hypothetical examples like the one we're doing. So in Uber, Uber actually had 2 instances where the credentials were exploited. Now, one was because an employee of Uber did exactly what I just did. They just pushed credentials in a public personal Git repository. Now, the key is that this was actually code for Uber, and I'm not sure what caused it. Perhaps they got confused with repositories. Perhaps they misconfigured their Git. But this ended up publicly on that employee's personal GitHub account. Attackers found it, and it gave access to an Amazon S3 bucket where they were able to gain access to sensitive information. They also had another example where in a private case where they had a private Git repository, so not public. And inside this, there was also Amazon S3 buckets that were hard-coded into the source code. So how did the attackers find these? Well, it was actually because of poor password hygiene. So there's some employees were using the same passwords for multiple systems. I think some of those other systems were compromised, and then they use that password to gain access to Git repositories where they found the sensitive information. So this illustrates kind of quite well both the public and the private aspect of not having secrets inside your source code. Now, another example, and probably one of my favorite ones, is that of CodeCov. So CodeCov was compromised early last year in a supply chain attack. So we just heard from Laurent about some supply chain attacks. So I want to talk about the CodeCov supply chain attack. So firstly, what is CodeCov? So CodeCov is a code coverage tool. Basically, what this tool does is it tests how much of your code is being tested by the other tools. It gives you a report of how much of your code is being tested by the other tools. So it does a very specific job. It sits in your CI/CD pipeline. Personally, I think it's a great tool. But this would be one of multiple tools that you would have. At the time of their breach, they had 20,000 users. So it was a significant user base. And some large companies, which I'll talk about, were using CodeCov. So what actually happened? So in CodeCov's kind of public main Docker image, so anyone could have downloaded this. This is a Docker image that people were using to run CodeCov. Inside this Docker image, there was a plain text file, a plain text credential, I should say. This credential gave access to their source code. So it gave access to the ability for them not only to be able to access the source code, for also be able to update their source code. So the attackers found this plain text credential in, again, their public Docker image. And once they had that, they were then able to inject some malicious code into CodeCov's code base. Now, they did it in a bash uploader file. It was a fairly ugly file. It was thousands of lines deep, and they injected just one line of code. And that line of code did something quite specific. It basically said, every time one of CodeCov's 20,000 customers is running it, take all the environment variables that are available and send them to me. Send them to the attacker. So when you're testing your application has to be able to build, it has to be able to run. So you have secrets in your environment variables, right? You have to access your database, your systems. Now, hopefully, you're using different credentials to test than you are in production. But it's not always the case. And it's certainly not the case that test credentials aren't always sensitive, because the adversaries were actually after a specific credential. They were after the Git credentials, the GitHub tokens for these customers, because this was something that was in the environment variables when CodeCov was running. So what were the attackers able to do? They were able to move from CodeCov's Docker image into their source code, turn their source code to their application malicious, and then move into the private code repositories of CodeCov's customers. So who were these customers? These customers were people like Twilio, Monday.com, HashiCorp, Rapid7, large companies with great security posture. The attackers were able to access the private source code of these companies. And these companies, the ones that I've just named, had to report that not only was their source code breached, but actually they had secrets in their source code. Now that included HashiCorp. HashiCorp is a fantastic company. They coined the phrase secret sprawl, and they build one of the best secret management products out there. And even they had secrets in their source code. So I'm willing to bet anything that if HashiCorp has secrets in their source code, you probably do too. And source code isn't impenetrable. This is one example how even if you do nothing wrong, adversaries can perhaps access your private source code. So this is a great example of kind of that supply chain attack going on. Now, the other thing to think about with private source code is that they don't always remain private. All right, we have hundreds of headlines about private source code being made public, or as I like to call it, involuntarily open sourced. So we have a lot of examples about these, and this is another area where your source code in and of itself can be a vulnerability. And I really like to kind of focus in on that point, because we know that our application can have a vulnerability, and we know that that application can have a vulnerability because of maybe something we did in our source code, but also our source code in and of itself can be a threat, can be vulnerable. So if we look at Twitch's source code, for example, that last year in October, their source code was involuntary open sourced via a torrent. We scanned Twitch's source code and we found over 6,000 secrets inside here. Now, that may sound like a lot, but at the scale of Twitch, it's actually pretty standard. In fact, Twitch beats the industry standard of what we typically would find in private source code for secrets. But that doesn't matter because we still found 194 AWS keys in Twitch's source code, 69 Twilio keys, a bunch of Google keys, and a whole bunch of other really sensitive information. We have a whole report on it if you're interested. But this just goes to show that private source code doesn't always remain private. And when it does leak out publicly, it can leak out a whole bunch more than just your source code. Now, in my opinion, the attackers in this exact example actually did Twitch a favor. They did Twitch a favor because they publicly announced that Twitch's source code has been breached. Had they not done this, then Twitch may not have known that all these secrets inside were compromised, because they were very quickly able to rotate a lot of these secrets so they were no longer a threat. But the attackers could have sold them. It happens regularly on the dark web, where you can sell credential accesses into companies. So it could have been a whole bunch worse. Now, another example is that of Samsung, Nvidia, and Microsoft. Now, this year, a lot of source code from these companies, again, great companies, were involuntarily open sourced. And again, we were able to scan these and found huge amounts of secrets inside of them. I'm just going to talk about a specific type of secret in the case of Nvidia. And that is that the Nvidia had their signing keys inside their Git repositories. And these signing keys were actually used to sign malware intended for Windows. So they were able to basically authenticate software that was actually malware, and it was accepted by Windows machines because of NVIDIA's signing keys that were in their private repositories. Now, this breach is actually a result from the Lapsus group. Now, we later found out that Lapsus was a group of teenagers. So this leads you to the question, how did a group of teenagers breach the private source code of some incredible companies? Samsung, Nvidia, Microsoft are fantastic companies with great security posture. So how did they do it? Well, here's a screenshot from the Lapsus Telegram channel, basically saying that they're after insiders. They're trying to recruit insiders. Specifically, the message says that we're recruiting employees, insiders at the following, and then they give a list of different companies. So I want you to think now about your source code and who has access to it. So when we're thinking about our secrets, I've said a lot, it's my favorite phrase, that they're the crown jewels of your organization, right? And as such, most companies will have great secrets management. They'll be tightly encrypted. The access to those secrets will be tightly controlled. So not everyone should or would have access to them. In fact, a select group of people would have access to a select certain group of credentials. But if these credentials end up inside your source code, now think about who has access to your source code. Your engineers obviously do, your developers, your product managers probably do, your team leaders do, and even your interns would. So if someone's trying to access your company, should they try and attack the secrets management software, which would be near impossible? Or do they try and find a disgruntled employee, an intern that's had a bad day, and give them a couple of grand so that you can access their private source code? Well, that is exactly how Lapsus was able to breach and find secrets inside some of the largest companies that we have. So I want to talk now about a report that will show kind of the scale of this. How big of a problem are leaked credentials? So each year, so I work for GitGuardian. We're a secrets detection company. And each year we release a report called the State of Secrets Sprawl. And this report looks at a number of different areas and how frequently we find secrets inside them. So we look at secrets in public places like public GitHub. We look at secrets inside public Docker images. So we talked about CodeCov and their Docker image. And we also look at secrets inside private code repositories. And then we publish these results and what we found and the types of secrets that we found. So if you want to know how many secrets are exposed on github.com, 6 million secrets were leaked last year in 2021. So GitGuardian scanned every single commit made to github.com. If you pushed source code to GitHub, we scanned it. So 6 million credentials we found. Now, this was from about 56 million users. Now, GitHub claim they have 75 million users. I'm sure they do. But 56 million users actually pushed code to GitHub last year. So this is a huge volume of code. It's billions of commits. And 6 million credentials is mind-blowing. But it's not just us that kind of realize this. Adversaries realize this too, and they actively monitor places like GitHub for secrets. So at the start of this talk, I leaked a credential on github.com. Now, I leaked that in my personal private repository. I'm not very active on GitHub lately, so there's no reason why an attacker would be monitoring me. But what actually happens is that GitHub has a public API. And this API updates regularly. So basically, what happens on GitHub is not just public, it's broadcast. So if you leak something, it's being broadcast to anyone, and anyone can, who monitors the GitHub API. So that is why I'm fairly confident at the end of this talk, I'll be able to show some people that have tried to exploit the credentials that I've lost. But I'm not alone. 6 million credentials were pushed to GitHub last year. So a mind-blowing number. So what type of secrets were leaked? Well, the main category is what we call other. So other is basically secrets that that could be access to lots of different things. They could be secrets being used for internal services. They could be secrets, could be kind of private keys or certificates that we don't really know exactly what they do, but we know that they're secrets. The second biggest category is data storage. So your database access. Your Amazon S3 buckets, for example. All of these are highly, highly sensitive. They can contain highly sensitive information. We shouldn't be hard coding them into our source code. We should be handling them correctly, putting them as environment variables. But 21% of the keys that we found, over 1 million keys that we found were actually giving access to databases and data storage. 15%, so just under 1 million, were actually to cloud providers. You don't need to be very imaginative to know what you can do with a cloud provider key. You can set up Bitcoin mining if you're not very imaginative. You can launch DDoS attacks. You can divert computing power. Or if you really don't like someone, you can just rack up a huge bill by stringing together large computers and running up kind of unimaginable numbers. So 15% nearly 1 million keys last year that we found were for cloud providers. Then we also have kind of development tools and messaging systems and version control platforms and some other categories too. My favorite is messaging systems because they're not very protected, but it's very easy to launch an internal phishing campaign if you have keys that will give you access to the internal messaging systems. We found over 500 GitHub tokens in commit messages. So if you don't understand this, if you're not very familiar with Git, this is basically putting your password to your email in the subject line, right? So you're adding a message to say what you've changed and you're putting in your GitHub token. So why is this significant? Well, it just shows that there's still lots of ambiguity and misunderstandings about how Git works. People are obviously thinking that this is how you authenticate themselves. So these people could have access to lots of different information, but they're prone for big configuration errors, or even doing silly things like adding secrets into commit messages. And just very quickly, if we look at kind of some of the cloud providers here, we can actually see that the one secret that's on the right trend and that's down is AWS keys. We're finding less AWS keys at the end of the year than at the start. So that's great. And this proves that we can actually make a difference, because AWS has done a great job in raising awareness around the fact that their keys are actually sensitive and shouldn't be made public. But at the same time, we also have new providers like PlanetScale and Superbase that have come onto the market. And already, even just a couple of months after PlanetScale was kind of officially launched, we started finding secrets to these providers on public GitHub. So it proves that we need to be really far ahead of the curve if you're going to try and prevent leaked secrets from kind of ending up in public spaces. Now, the other area that we find secrets that we talked about is inside public Docker images. So this is Docker Hub. So dockerhub.com is the largest place that you can store your Docker images, and there's over 8 million Docker images that are currently available on Docker Hub. And this was actually where you would download the code Docker image. So we scanned 10,000 Docker images to find out how many of them had secrets. And we found that nearly 5%, 4.6% if you want to be pedantic, contained at least one secret, one hard-coded plain text secret. So we found, out of the 10,000 that we found a total of 4,000 secrets. 1,200 of them were unique. So there was quite a few secrets being repeated inside those Docker images. But again, it can be very confusing of kind of how to build Docker images. We see a lot that people add in a secret, let's say to a package manager so they can access it in their Docker file. Then they remove it later because they know that it shouldn't be there. But actually, like Git, you can go back in history. Same with Docker. You can go back in history when you build something. It's built in layers. If you add something in the first layer and then put layers on top of it, that secret still exists. So we found a huge amount of secrets inside Docker images. And the last area that I want to talk about before we kind of go back to the experiment is how frequently are secrets in private repositories. So people have this false sense of security around private repositories that because it's behind some kind of authentication, that it's secure. But we just proved that source code is very leaky. Lots of examples of involuntarily open sourced source code. So how much do we typically find inside private source code? So at GitGuardian, we took the average of our larger customers. So our larger customers, the average of them was a company with about 400 developers, so 400 engineers. So a fairly sizable company. Now, in a company this size, we found around about 1,000 unique secrets. So that's huge. So we look at Twitch. Well, Twitch is a whole lot larger than that. We found 6,000. It's pretty much on par. So it's a huge problem. And, unfortunately, attackers know this too. Now, each one of those 1,050 secrets were actually repeated on average 13 times throughout the Git history on different branches and in different areas. So why is that significant? Well, every time you find a secret, you have to investigate it. It doesn't matter if it's the same secret, because you're probably not aware of that. So if there's 13 of the same secret, it's going to have to be investigated 13 times. Now, in a company of 400 developers, there's typically 4 AppSec engineers. That means that each one of those AppSec engineers has to investigate, kind of communicate with the developer, rotate, republish their keys 3,400 times a year. That's huge amounts. If you did that all day, every day, and nothing else, and didn't work holidays and weekends, you still wouldn't be able to get through it. So this is how big of a problem that we have. And unlike us, attackers have time on their side. They can sift through that amount of information to find that gem, but we're under pressure. So this illustrates the importance that not only do we need to be aware of this problem, but we also need education and tools to be able to prevent it. So quickly, why does this happen? Well, it happens for a number of reasons. We've talked about a few of them. Misconfigured Git repositories, secrets buried in the history. We have to understand that just because it's not in our current version doesn't mean we can't find it. It could be on an obscure branch. Secrets exposed in logs or generated files, including sensitive files like env in our repositories. And also, we're just seeing a lot of people actively managing secrets in Git repositories, not understanding how big of a problem that is. So let's have a look at our experiment. So about 20 minutes ago, we leaked a credential into GitHub, public GitHub, github.com. This is how many times people have tried to exploit it since I've been talking. Now, I do want to clarify a couple of things. A lot of these IP addresses will be the same. They'll be initially making a ping to try and find information. So if we open up one of them, we can see that this is from Germany, and they're trying to find the account attributes. While other people will probably be looking at different calls. So here, they're trying to get the caller identity. So they may be initially trying to find caller identities and then get more information as they go. But a lot of these will be unique. I see at least 3 countries here. So in just 20 minutes, a whole bunch of bots really have tried to exploit this secret. So this just goes to show that if you leak a secret, even if you catch it quickly, even if you're aware of it and go back and remediate it, people still probably have found it. Now, I'm running out of time. I'm getting to the end, but I just want to make a kind of a quick word before I close up on how to prevent this. Well, we need to use secrets management systems. That was something that I think Lewis brought up as well when talking about Kubernetes. We need to have good secrets management to be able to prevent this. There's big tools like Vault. There's key management systems that you can use if you're using cloud services. Understand what tool is going to be right to use. And here's the key. Make sure it's usable so you actually use it. Never store secrets inside your Git repositories. I know it's tempting. I know, because it's a great way to share important information with everyone, but we never should do it. We have to make sure that we're using environment variables or other methods that we're not hard-coding them. Use short-lived credentials where possible, or even better, dynamic credentials so that they're being generated just in time. So this means that if a credential is exposed, you've set up a policy or you've set up a routine of rotating them so that it will not be a threat anymore. Restrict access. The last one, or the fourth one, restrict access to certain areas so that even if a credential is leaked, that means that not anyone can use it. They have to be coming from a select IP or a select area. And then finally, we need to add automated secrets detection. So there's lots of different ways to detect secrets. GitGuardian is who I work for. We have automated secrets detection, but we're not the only ones. There's open source projects out there too. Of course, I think GitGuardian's the best because I'm biased. But the important thing is we need visibility. So whatever tool is going to work for you, then that should be the tools that we're using. So that's it from me. If you want to learn more about the research that I presented, here's a random QR code. I promise I won't do anything malicious. But this will take you to a report called the State of Secrets Sprawl report. It will provide more information about what I talked about. So if you want to learn more, you can find out about that. And I have a link down below, or you can follow me on my social media handles. But I would like to thank everyone for putting this together, and thanks for paying attention. It was really fantastic to be able to present to all of you. Even though I can't see your faces, it's still great to have the opportunity to be able to talk about this to everyone. So thank you.
That was fantastic, Mackenzie. And I'm sorry, but based on past sessions, I don't think I can really trust you to scan that QR code and believe that it isn't doing anything malicious.
Do you know what? I don't blame you, but the URL is a little bit long. I think I'm always amazed that even in like security conferences, people will still scan it. So I'm gonna still put it up there to see what happens.
It is convenient, but that's sometimes how things go, right? When it's convenient, that's how you get caught.
Exactly. Yeah.
So I had questions coming up, but you were always answering them in your presentation. So props to you on that. I guess the only one I would ask that maybe, I don't know if this is really a question to be asking because it's not necessarily something that's going to solve the problem, but like, are there any consequences for the folks that are doing malicious things when they're exfiltrating they're getting these keys and that kind of thing? Is there something happening in the world right now to like cause maybe deterrence for people from doing something like this?
There's not really that many deterrents for doing this because keys are so widely used by different people. It's it's hard to even know who the attacker is. So we can find out their IP address, but that's probably not their computer. That's probably a service that they're using. It's probably obfuscated a little bit, so it's hard to track down. the onus, unfortunately, in security is on us. And not the bad guys. And hopefully there will be a change in that. But, to talk about how ridiculous actually, this problem is that there was a developer working for DJI that leaked a credential. That developer, right? It was an honest mistake, and it happens to everyone. And most companies would never do this. Most companies understand that this happens. But DJI had some reputational damage because of that. And then they prosecuted their employee, that developer, for leaking a secret, which is terrible. So, we need to change the game a bit. We need to be able to have more kind of consequences for that, because at the moment we're focusing totally on the wrong things. We're humans. We're gonna make errors. It's just how it is.
Yeah, absolutely. Eric, anything to add?
It's just like a fire hose of information. It was awesome. I was curious if maybe this is in your report or you have an opinion. What about things like sealed secrets, where you're encrypting your secret data in Git and then you're having to decrypt it after the fact? Any experience with that? Any thoughts?
So, like there's the security line that you should take, and the security line that you should take is that you shouldn't do that, because that sealed file, so you're encrypting it, is still going to sprawl everywhere and it's going to create risk. The security line is that you should use something heavy and complicated like Vault, and you should if you're a large company. I have a different opinion. So I have an opinion that we need to be using secrets management, but we need to use appropriate secrets management for where we are and the risk that we have. So, if you're a team, if you're a small team, if you're working on some local projects, as long as it's using good encryption, it does increase your risk because it sprawls even though it's encrypted. But if we can rely on that encryption and we can make sure that we don't leak those keys, then it can be a good solution. If the alternative is that you're just going to share the secrets in plain text, right? Because secrets management can be so heavy. So I'm not so against that if it's appropriate for your, if it's appropriate for what you're doing. If you're a large company, you shouldn't be doing that because you're a target. You should be using these heavy, great software, but they can be expensive. They can be hard to set up. So yeah, I mean, I kind of get that, and I think that because it can be so complicated, I mean, that's infinitely better than just storing them in plain text in Git. So if that's convenient for you, if you're actually going to use that method, then sure, that's a step in the right direction. And as long as you grow with your maturity, then I think that's a fine first step. But the official line is no, don't do that. just to cover.
All right, one last question for you, Mackenzie, before we let you go. And this one comes from Nicholas over on Hopin. They ask, are there any tools suggested for scanning Git history and Docker images to list/hash all found secrets to use during remediation and ensure rotation?
Yeah, absolutely. So I work for GitGuardian, so we're a tool that does that. We're free for developers or anyone with less than 25 developers in their team. We'll scan your entire history. You'll have a nice dashboard. We also have some open source tools for it. So obviously, that's the tool that I recommend. And we can also scan, Docker images and all these areas. So GitGuardian, for sure. But I always like to mention some other areas. If you kind of were looking more at open source projects, there are some great open source detection tools out there. They don't work in that large scale enterprise things because they can get pretty noisy. But if you're just wanting to experiment with secrets detection, GitGuardian's free, but there's also open source alternatives out there as well. So if you do a quick Google search, if you look into it, you'll find some great options and ones that will fit into your workflow, I'm sure.
Excellent. Thank you for that answer as well. And thank you for a wonderful session, Mackenzie. We're going to let you go. Have a good rest of your day, and I hope to see you around again soon.
Awesome. Thanks, guys. It was great to be on part of it.
Thank you.